So in this video and the next video in this lab, we're going to talk about working with model data using Simio tables and also external data sources. And we're going to talk about these topics in the context of the familiar subway example that we have seen a couple of times in the previous video labs. So we have different stages in our system. So we have the first stage in which customers choose the bread and meat, and then they go to the oven, then they go to the veggie station to put vegetables on their sandwich, they pay at the cash register, they get the drink at the drink machine, and then they leave the system. So similar to what we had before, we were going to assume an arrival rate of 32 customers per hour. But this time, we're going to have 4 different customer types. So as you can recall, previously we only had 2 customer types, hot and cold customers. This time we have 60% of the customers that get their sandwiches toasted, 25% get cold sandwiches, 10% only get a drink, and 5% that only get cookies. So routing and service time data are given in an Excel file provided by the restaurant. So let's take a look at the data real quick. So in our Excel file, we're given 2 tables. The first table includes the routing sequences for our entities. So we have hot customers that go through all 5 stages. Cold customers skip the oven, so they go through the bread, veggies, cashier, and drink stations. Drink customers first go to the cash register and make the payment and then go to the drink machine, while cooking customers only go to the cash register to get their cookies. In the second table, we're given the parameters of the triangular distributions for our processing times on different machines per customer types. And as you can imagine, we expect to see different processing times on the cash register because the processes to process the customers at this stage is different based on the type of the customer. So as you can imagine, when a cold or hot customer goes to the cash register, the cashier wraps the sandwich, and then we have the payment process. While for the drink customers, they only make the payment and then they grab the cup and go to the drink machine. For the cookies customers, the cashier first asks the type of the cookie that the customer wants, and then the cashier wraps the cookies, and then we have the payment process, which is why we see different processing times on the cashier. This time we're going to assume that passing is allowed, so we don't have to maintain first in, first out throughout our system. And we are also going to assume that we don't have bulking. So before we go to Simio and start building this model, I would like to do a quick recap on the 2 models that we built in the previous labs based on this subway example. So here is the first model that we developed, and as you can recall, we had at that time only 2 different customer types, hot and cold customers. And in order to handle the type-dependent processing time on the oven, we used a discrete probability function. So with a probability of 30.3, we have a processing time of 0. That is, we have 30% of the customers that get cold sandwiches, and the remaining, that is, with a probability of 0.7, we use a triangular distribution for our processing time. However, let's consider our current problem where we have different processing times and the cashier for different types of entities. So I have the hot customers that go through bread, oven, veggies, and get to the cashier. I have cookies and drink customers that go directly from the source to the cashier. And I have cold customers that go to bread, they skip the oven, the veggies, and then cashier. So as you can see, entities go through different routes before they get to the cash register. And I cannot simply sample their processing times here because it is possible that I assign the wrong processing time to my entity. In the other model that we developed based on based on the Subway restaurant. Again, we only had two different customer types at that time, and we used add-on processes to handle different processing times or type-dependent processing times on the oven. So we defined a model entity state variable. We called it proc time on the oven, and then we used an add-on process at the source object, at the output node of the source object, to basically assign values to our proc time on oven model entity state based on a probability based decision that we make using this decide step. So with a probability of 0.3, we have a 0 processing time on the oven, and with a probability of 70%, we have our triangular distribution. And then on the oven, we use this expression right here. The problem with this approach is that for the cases when we have many different customer types and different routing sequences for our customers, the modeling process becomes very tedious. Because as you can imagine, for multiple entity types, I will have multiple decide steps to determine the type of the entity and then make the corresponding assignments. And also, I need to handle the different routing sequences for my entities all in the model using their link weights and using processes. So as you can see, the model can easily get complicated when we have many different customer types, which leads us to an alternative approach that we're going to talk about shortly. So let's start building the basic structure of our model here. So for this model, I'm going to need a source object. Let me zoom out a little bit. And I'm going to need 5 server objects. 1, 2, 3, 4, 5. And also a sync object to destroy the entities when they leave the system. This time I'm going to use 4 instances of the model entity object definition for my 4 customer types. And let me go ahead and rename my objects here. So my first entity type is hot, I have cold, I have drink customers, and I have cookies. Let me fix this problem here. Drink cost. I would also like to rename my servers. So I have bread, I have the oven, and then veggies, have the cashier, my drink machine, and my sink, which I don't want to rename at this point. So now let's go ahead and put the connectors that we need for this model. So we know hot customers go through all of these stages. So let me connect all of these up like this. We know cold customers skip the oven, so they still go to the bread, but they skip the oven and go to the veggies, and then they go through the rest of the stages. I have drink customers that go to the cashier first and then go to the drink and leave the system. I have cookies customers that go to the cashier once they enter the system, but they don't go to the drink machine, and they leave the system directly after they make the payment. So it looks like I have all of the connectors that I need from my model. Let me just run the model real quick to make sure that everything is connected and I'm not missing any links. The next thing I'm going to do is changing the symbols for my entities. So I'm going to use a red symbol for a red color for my hot customers, a light blue color for my cold customers, and drink customers I'm going to leave them at the default green, and then for the cookies I'm going to use a brown symbol. So let's go to the Data tab and see how we can create our related tables here. So in this model, we're going to have two related tables, a part type or a customer type table and a sequence table. So let's go ahead and create our first table, which is a customer type table. And we're going to call it customer types. And the table is going to have two columns. My first column is an object reference property to an entity. And as you can see in the drop-down list, I have my customer types here. So let me go ahead and rename my column heading to cust type. And let me go ahead and put in my customer types here. So hot, cold, drink, and cookies. And I would like to set this column as a key so I can use it in the other table that I defined so I can have related tables in my model. The next column that we're going to add to this table is a standard property column, which is going to be our mix of customer types. And I'm going to use an integer property here. So I'm going to call it mix. And this is basically the percentages, the distribution of customer types. So I have 60% of the customers that are of type hot. We have 25% cold. We have 10% drink customers and 5% cookies based on the data that have been given to us. So now that I have my first table complete, I can go back to my facility view and tell my source object to use references to my data table. So I'm going to tell my source object that I need my entity types to be selected from my customer types table and specifically the cust type column. So now I'm referring to my data table to determine the type of my customer. But I also want to make this determination based on the probabilities that I have defined in the mix column. So I'm going to go to the table reference assignments properties category and for my source object. And before creating the entities, I'm going to specify the table name, which is going to be customer types. And I would like to randomly pick the type of the customer based on my mix column. So I'm going to have my customer types table, and I'm going to use the mix column and a random row to determine the type of the customer that I create. So now when I run my model, I'm randomly creating entities. Let me slow down a little bit. So as you can see, we see different colors, different entities that are created randomly based on the mix that we specified in our data table. Now let's see how we can handle different routing sequences and type-dependent processing times using a related table and specifically a sequence table. So what I'm going to need is a sequence table. So when I create a new sequence table, I already have my sequence column here. And since I want to relate this table to my customer types table, and specifically the customer type column in our table, what I need is a foreign key property, and my table key is going to be customer types dot cust type. So now I'm referring to this column in my customer type table. And I'm going to rename this column. I'm going to just call it cust type. Cust type. So I have my two columns here, and the third column I need is a standard property, but this time an expression property for the service times. So I'm going to call this service times. So now I can go ahead and fill my table. So let me just move my customer type column to the left so that it appears on the first column in my table. So now I can use a drop-down list to fill out my table. So for hot customers, they first go to the input at bread, and I will leave the service times empty for now, since I'm going to use Excel to type those in. And then again, for my hot customers, they then go to the oven, and then they go to the veggies station. Then my hot customers will go to the cashier, and after that they will go to the drink machine, and after that they'll leave the system. So similarly, I can go ahead and define my sequences for my cold customers. So they first go to the bread station, and then they go to they skip the oven and then directly go to the veggies station, and so on. So the next thing I'm going to do is to complete my table, my sequence table, and after that I will show you how we can export the table to a CSV file in order to complete the table. So here is my sequence table with the first two columns complete. So I have my customer types and the sequences that they need to follow, but I haven't specified the service times yet. So one approach is to simply type the expressions in Simio. So I can have random.triangular, and if I remember correctly, for the hot customers on the bread station, we have a minimum of 1 minute, mode of 1.5, and a maximum of 2 minutes. So let me go back to my data to verify that. So it looks like we have it right. And so I can continue and type the expressions in. Alternatively, I can export this table to a CSV file and complete the table in Excel, which for me is easier to do. So I can go ahead and export my table to a comma-separated value file, a CSV file. So I'm gonna save my file. And when I open my sequence file here, you will see that we have the table exported to our CSV file. So we have the headings here, and we have the customer types and the sequences. So I can go ahead and simply fill out the service times in my CSV file, and then I will show you how we can bind this, bind our sequence table to our CSV file that we just created. So here is my complete sequence table in my CSV file. So as you can see, I have my 3 columns and my service times all complete. So I'm going to close this CSV file, save it, and then go to Simio. If I don't close the CSV file, I won't be able to import it in Simio. So I'm just going to import the data by binding my sequence table to a CSV file, and the file is going to be my sequence table. And I'm going to leave this check mark here. The first line contains column headings. And then I say OK. And what happens, my table is now bound to my CSV file. I'm just going to go to binding options and set the binding options to manual, so that every time that I want, I can reread the data into my sequence table. If I set it to automatic, it will import the table's data at the start of every one, which is not something that I want at this time. So manual and import. I clicked on export by mistake. Import. So now here is my sequence table with service times and all the information that I need. So the final steps to complete the model involve telling the server objects that we would like to get the processing times from the sequence table, and also tell our model that the entities will pick their destination node based on the sequence. And we also need to set the arrival rate. So let's do the processing times first. I'm going to select all of my servers by holding down the control key. And for the processing time expression, what I'm going to use is my sequence table and the service times column. Say OK. So now my servers refer to my sequence table to determine the processing time of the entity based on its type. And now, in order to make sure that the units are correct, I go back to my table and set the unit type to time, and instead of hours, I want them to be in minutes. So now we have set the processing times. Let's do the routing logic. So I'm going to hold down the key, the control key, and select all of my output nodes. And this time, I'm going to tell Simio that my entities choose their destination based on my sequence. So entity destination type properties for all of my output nodes will be set to by sequence. And finally, I'm going to specify my arrival process, which and I know my inter-arrival time will be 1/32 per hour, and the units are in hours. So now when I run the model, hopefully if we have everything implemented correctly, we should see that blue ones, which are cold customers, skip the oven. Red ones go through all of the stages. And we should see cookies only at the cashier, and the drink customers at the cashier and the drink machine. So to recap what we did in this video, we first defined a customer type table, a data table, and we specified the mix and the type of the customers, and then we defined a related table, a sequence table, to specify the sequence of the stages that entities follow, and also the processing times on the corresponding step. And we used foreign keys to relate the two tables together. So we set the customer type column of the first table as a key, and then we used a foreign key to relate to our first table. So now when I click on this little drop-down menu here, you will see that for my hot customers, I can also see the sequence in my first table. So that's how the two tables are related together. And then what we did, we told Simio to get the processing times for customers from the service times column in the sequence table, and also we at the output nodes of our servers and the source object, we set the entity destination type to by sequence. Now, also note that you can modify your tables either in Simio or in the external data table or data source that you have. So for example, if you want to modify the sequence table, you can either go to the CSV file that we created and then import the data again after you make the modifications, or you can simply or directly modify or make modifications in Simio.